Happy last week of April, gentlemen. This video is designed to watch before you take the quiz in Delta Math called Circle Quiz 1. So, to start off with, I want to review inscribed angles versus central angles. If an angle comes from the center of the circle, that's called a central angle. And its measure is the same as the arc, and vice versa. So a central angle, in this case, would have angle A here, if you want to call it, would equal 100 degrees. And arc rather, MC, would also equal 100 degrees. So the arc is measured from the central angle. Now, change colors, we're going to do an inscribed angle. An inscribed angle is any angle whose vertex is on the circle. An inscribed angle is 1/2 the arc. So in this case, we'll call this angle B, or angle MBC. It would be 1/2 of 100, otherwise known as 50. And notice we can draw inscribed angles in a lot of different places. I could put one over here, and since it's still, we'll call this angle X here, its intercepted arc over here is still this 100 degree arc. So angle X would also equal 50. So you could have numerous inscribed angles with the same arc. Now there's a special case when you have a semicircle. Center, go straight across, and change the color. Let's go blue. If you inscribe any angle in a semicircle, like here, and make sure the intercepted arc is a semicircle, you always get a 90 degree angle. Because the intercepted arc is 180, every angle on a inscribed every inscribed angle on a semicircle would always be 90. We could put some on top as well if you like. Do it in orange, I guess. So I'll put a point here. If that goes from here to here and here to here, you're always going to get 90 degree angles. So inscribed angles in a semicircle, as long as the parts extend to the ends of the diameter, will always be 90 degrees. Okay. Now, so you got inscribed angles are half, and central angles are the same. Now, a couple other things that came up maybe on the last homework, there's a couple problems on your quiz about this, and that is when you have to complete the square in order to figure out a circle. So let me do this. Let's say you have the following problem. X squared plus 6x plus y squared minus 8y minus 11 equals 0. And you have to graph this and figure out where the center and the radius are. Well, you want to make this a perfect square trinomial. So what we're going to do is complete the square. So let's take this first two. X squared plus 6x. If you remember, when we complete the square, we cut the 6 in half and square it. This then becomes x plus 3 quantity squared. Remember, whatever this number here is, that's what goes inside. Change colors and do the y part here. This would be half of negative 8 would be negative 4. Squared would be 16. So I get y minus 4 quantity squared. Now we added 9 and 16. So here's where it gets tricky. First of all, we're going to throw the 11 over here. Add 11 to both sides. Then to keep it balanced, we have to add 9, and we have to add 16. Well, 11 plus 9 is 20, plus 16 is 36. So that's the part on the right. So your equation then, when it's all said and done, x plus 3 squared plus y minus 4 squared equals 36. So this circle would have a center at -3, 4, and the radius is the square root of 36, otherwise known as 6. So you have to complete the square on both parts. Okay, so there are homework problems like this in the last assignment we did, but there's a couple quiz questions like this as well, so you have to know how to complete the square. This part here, let me put it in green, I guess. Sometimes I'll have it on this side, and sometimes I already have it on the other side. Just remember, you have to always have it on the right-hand side. If it's already there, great. If not, you have to move the -11 by making a +11 on the other side. Okay. Lastly, a problem where they give you coordinates and you have to come up with the equation. Something like this. Let's say the circle is over here, and we'll say the center is -4, 6. And a point on the circle, change colors, up here is -110. I'm just making this one up. Find the equation. Well, the first part's easy. Since the center is -4, 6, that would be x plus 4 squared. Because remember, when you plug in a center, you should always get 0. Plus y minus 6 squared, and I'm running out of space, equals what? Well, it's the radius squared. Well, the radius here would be this little piece right there. And what I always do is kind of make it a right triangle. So from -4 over to 1 means we ran a distance of 3. From 6 up to 10, we ran a distance of 4. So by Pythagorean theorem, 3 squared plus 4 squared, 9 plus 16 would give you a 25 up here. So the radius squared would be 25, or radius would be 5. So we just put down 25. So that's how you get the equation given a circle. Just use the distance formula to find the radius, or if you like, make it a right triangle, count over and up or over and down, square both pieces, add them together, and it always gives you r squared, which is the radius squared over here. Okay, I hope that makes sense. Go ahead and take the quiz. You should get about 25 questions of mixed varieties with arc measures, central angles, inscribed angles, and equations of circles. Good luck.